Why does a push button switch turn off its output the moment you release the button? And how do you make it stay on? In the previous video, we covered PLC basics, contacts, coils, variables, and ladder logic structure. Today, you'll learn how to use memory functions with bistable blocks in OpenPLC. There are two types of bistable blocks, SRO and ROS, the same as set reset and reset set. A bistable block is a memory element that stores true or false states inside your PLC until a change occurs. That is why it is called a latch. Now add a new ROM and drag the SRO block onto it. The output Q1 is set to true when the set input is true, even when the reset input is also true. Drag a contact with the button 1 variable to the S1 input of the block, and a coil with the LED variable to the Q1 output. Assign the button 2 variable to the arrow input of the SRO block. Ensure the OpenPLC simulator is selected in the device configuration, then run the simulation. When button 1 is forced to true, the LED output becomes true and remains true even after the force is released. The output only becomes false when button 2 is forced to true. While button 2 is still true, force button 1 to true and observe that the output still becomes true, indicating that the set input takes priority over the reset input. This block function is ideal for fault notifications that must not be suppressed while the fault is still active. Exit the simulator, change the block to the ROS type, and assign button 2 variable to the arrow input. The output Q1 is set to true when the set input is true, but it becomes false when the reset input is true, even while the set input is still true. Start the simulator and force button 1 to true. The LED output changes to true. Force button 2 to make it true, while button 1 remains true, and observe that the LED output becomes false. This indicates that the reset input takes priority over the set input in this case. This function block is suitable for a fail-safe equipment where a stop is required to overwrite the start. Edge detection blocks detect a trigger such as a button the instant it is pressed, using the rising edge block, or released using the falling edge block, not when it is held down. Now add a rising edge block between the button 1 contact and the ROS block, then start the simulation. Observe that when button 1 is forced to true, the rising edge block momentarily pulses the input of the ROS block. However, with the falling edge block, the output only pulses when the force on button 1 is released. Now, let us combine the bistable and edge detection blocks to produce a one-button toggle program. Delete the existing ROM with its blocks and add a new ROM. Add a contact, a rising edge block, and a coil to the ROM. Assign button 1 to the contact and add a new pulse variable to the coil. Add another ROM with 2 contacts, a coil, and negate the second contact. Assign the pulse variable to the first contact, the LED variable to the second contact, and a new set signal variable to the coil. Duplicate this ROM, change the second contact to normally open, and add a new reset signal variable to the coil. Add a final ROM with a contact, the SRO block, and the coil. Assign the set signal variable to the contact, the reset signal variable to the reset input of the SRO block, and the LED variable to the coil. Go to Device Configuration and select the ESP32S3 board or any other board of your choice. Ensure that the correct COM port is selected. If you followed the last episode, you should have your pin mapping done like so. Then compile and upload to the selected PLC board. Observe that when the button is pressed, the LED turns on, and when pressed again, it turns off. Thanks for watching. What happens when you combine memory with time delays? In the next video, we will cover IEC 61131-3 timer function blocks in OpenPLC. Don't forget to subscribe, like, and leave a comment. Bye for now.